Number 1. Number of nodes, I can just count it. 1, 2, 3, 4, 5, 6. Height. I can check level 0, level 1, level 2, so height is 2. Depth of B. Depth of B is 1 because depth of A is 0. Length of longest path, I'm going to change this one to the width. So left to the right. So 1, 2, 3, 4. So longest left to the right traverse is at length 4. Then root is node A. Then number of leaves, which has no child, D, E, F, so 3. That means the number of parents is A, B, C, so 3. Number of only child, which has no sibling, that is only F, so 1. Then number of nodes at level 0 is always 1 because level 0 is a root. Then preorder. If I do preorder, up, left to right, so A first, then left to subtree is a preorder, so up, left to right, so B, D, E. Then on the right side, it has up, left to nothing, so C, F. If it's in order, left to up, right, so D, B, E first, then A, then F, C, nothing. And post order, left to right and up. So D, E, B is left, then right, F, nothing, C, then A. Level order, level 0 has A, level 1, B, C, level 2, D, E, F. That's how to get level order. Then let's see this tree. This tree is a binary tree, but not binary search tree because D is greater than A. But this is complete because all the way left is filled at level 2 and level 1 is full filled. And also left subtree, right subtree has the same height. That means balanced. Let's see number 2 first. This is a binary search tree because left is smaller and right is bigger. And each parent, left is small, right is big. So binary search tree. Then this is also balanced and full because the bottom level is fully filled. Number of nodes 1, 2, 3, 4, 5, 6, 7. Height is 2. Then level of 5 is 0. Width is 4. So left to the right 1, 2, 1, 2. So it's 4. Then root is 5, node 5. Then number of leaves 1, 4, 6, 9. So 4. Then number of parents is 3. Number of only child is 0 because it's full. Then number of nodes at level 2 is 4. Then preorder 5, 3, 1, 4, 8, 6, 9. In order 1, 3, 4, 5, 6, 8, 9. So you can see it's in order. Post order 1, 4, 3, 6, 9, 8, and 5. Level order 5, 3, 8, 1, 4, 6, 9. Now let's just see the code, how to search in the binary search tree. So by using this code, this tree, I can start from the root. So the tree is empty means you can say the current node is null or not. So when I compare with 5, the root, then the first one is not true, so else if the item is equal to target, no, so else if the item is greater than, the root is greater than the target, no, so else. Go to the right subtree. So you are going to call the recursive call. So now you are going to think the right subtree is the whole tree. So 8 is the root in the recursive call. Now you are going to check. Compare with the target 6. First one is not true, second one is not true, then third one, yes, the root, current root is greater than the target. Now this is the correct, so you're gonna go to the left subtree. So recursive call by calling the left. Now you're going to compare. It's null? No. It is the same? Yes. Then you're going to return true. So how many recursive calls were there? First call, second call, and third call. Yep, very good, Vivian. How about if we want to check 7. First, I'm going to compare with root. So that is the first call. Then go to the right. Then compare with 8. That is the second call and go to the left. Compare with 6. That is the third call and go to the right. Then there is actually no. Now go to the tree structure again. Then tree is no empty. Yes, so return false. So that was the fourth call. Binary search you can do only at the binary search tree because the items should be in order. Now number 4. Number of nodes are 10, then there is a level 0, 1, 2, 3, so height is 3. Depth of D 0, 1, 2. Width is from the bottom one of the left, so 1, 2, 3, 4, 5, 6. And root is node F. Then number of leaves, A, C, E, G, I has no child, so there are total 5. That means the number of parents are also 5 because sum of them equals the total number of nodes. Then only child, that means which has no sibling. A has a sibling, CE has a sibling, G has a sibling, but I has no sibling, so only 1. Then number of nodes at level 3, there are 3 nodes are there. Then pre-order traverse. Pre-order means up, left, right. So F in the subtree, B, A, then subtree. B, A, then subtree is DCE. Then on the right side, up, left, right. So H, G, then up, left, right. So J, I, nothing. In order, left, up, right. So I can say left, up, right. Left subtree first, A, B, then right subtree, C, D, E. Then up, F, then on the right subtree, G, H, then on the right subtree, I, J, nothing. Up, A, B, C, D, E, F, G, H, I, J. So in order is in order, that means this tree is a binary search tree. Then post order, left, right, and up. So A, then right has the subtree, so C, E, D. Then up, that is B. So left subtree is done. Then right subtree, in the right subtree, left is G. Then right subtree is J, I has nothing. I, nothing, J. Then go to H. Then go to F. So that is the post order. Then level order, level 0 has F. Level 1 has B, H. Level 2 has A, D, G, J. Then level 3 has C, E, I. That is the level order. Then this one is not complete, is not full, because there is no child under A. But this is a balanced tree, because left subtree, right subtree has the same height. Now number 5, we call this kind of tree as expression tree. So it has only 2 child, so the name is binary expression tree. Binary expression tree, this one has 1, 2, 3, 4, 5 nodes. Then height of this one is level 0, 1, 2, so 2. Depth of times is 1. Width is 1, 2, 3. Root is plus node. And number of leaves, number of operands is a number of leaves, so there are 3. Number of parents and number of operators, so 1, 2. Number of only child in the binary expression tree, you cannot have only child. Then number of nodes at depth 1, there are 2. Then pre-order traverse, another name is a prefix. And prefix is plus 3 times 5, 4. Up, left, right. Then in order traverse, another name is infix. So left, up, right. 5 times 4. When we have infix, we can put some parentheses, but in the traverse, we do not add any other extra character. We do not. That's a traverse. Only infix, we add parentheses. Now, post order, we can say postfix. So 3, 5, 4 times plus, and level order plus 3 times 5, 4. Number 6, Number of nodes, 1, 2, 3, 4, 5. Height, level 0, 1, 2. Depth of asterisk times is depth 0. And width, 1, 2, 3. Root is times node. Then number of leaves, number of operands, 1, 2, 3. Number of parents is number of operators, so 2. Number of only child, there is no only child, so 0. Number of nodes at level 2, there are 2, 3, and 5. And preorder prefix, so times up, left to right. So plus 3, 5, then 4. Then in order or infix, left, right, left, up, right. So 3 plus 5, up, right. But in the infix, it's in order. Blue is in order. Then if we want to write infix expression, we are supposed to put the parenthesis here. Then post order, another name, postfix, left 3, 5 plus 4 times. Then level order times plus 4, 3, 5. How do you remember the orders for the traverse? I just draw a diagram. Pre, in, post. Pre means root is first, post means root is last. In means inside, has the root. Number 7, which one is complete? Actually, first one is complete, then sixth one is complete, but actually full we also say complete because full means full complete actually. So 2 is also. Now, which of the trees above are full? So easy, 2. Now, which one is a binary search tree? 2 and 4. Then number 10 we are going to do next time. I'll show you just one useful thing. I put the debug mark next to the tree node root equals null in the shellcode. I didn't write anything. Then if I click the debug, I'm going to see all the variables on the left. Then after tree node root equals null is done, now I can see the root. I'm gonna drag the root. Currently null. Then the next line is build tree. This is already given. And what is S? A string which has X computer science. Then I don't know what build tree does, but I can see that what does it do by clicking next. Then you can see a tree is built. This tree does not include the first character X. It has computer science, then it added A, B, and C at the end, some randomly. Now there's another method display, which is already written. Then if I look at after display, what happens? You can see something is printed on IO window. C is on the all the way left. Then O, M, P, U, T, E, O. You can see that this tree 90 degrees rotate to the left. So this is how display is working. C is root, O is left child, M is right child.